Thanks, Ian. So I'm Josh. I'm at Robb on Twitter. You can tweet me. I work for PushPay. I'm the VP of engineering there. I don't quite know how that happened. It seemed to happen very quickly. I'm not quite sure I like it. We're hiring. If you're a tester, we'd love to talk to you. If you're an engineer, we'd be really interested in having a conversation. And as Ian said, this talk is really about how to make better design choices when writing code. And what I'm talking about is not abstract design on a whiteboard or with UML diagrams and sequence diagrams, but actually, like when I'm typing, how do I make informed choices about how I improve the quality of the code as I go? And I think most of us here don't work on new systems that are perfectly written. Most of us work on code that's pre-existed, some of it for a very long time. And for me, one of the big challenges is every day when I come in, how do I leave things better than I found them? And so throughout my career, I've been seeking kind of ideas and concepts that help me work towards that objective. Sometimes I make things worse and I don't realize it for a long time, but that's what I want to know. So I want to do better code. How do I do it? And I think that the fundamental problem is that the way that we talk about software design is all wrong. The things and the techniques and the messages that we send are really unconstructive and unhelpful. And so I want to present what I think is a grand unified theory of software design that's simple and easy to apply and not at all grandiose, not even a little bit. And one of the things that's motivated me to start talking about this is that we do a lot of code review at PushPay. Every piece of code that goes into production, that goes into master, is code reviewed. And it turns out it's really hard to teach people how to code review well. If you take people and you say, do code review, and you don't give them a framework, then what they tend to do is focus on trivialities. They look at, oh, you've got your braces in the wrong position, or you use tabs and not spaces, or whatever. Once in a while, someone might pick up a glaring security vulnerability with SQL string concatenation or something. But most of the time, they don't focus on the things that are important, which is this moving the bar? Are we raising the boat for everyone, or are we just making things worse or leaving them the same? And so I've been looking for ways to talk about it. And for a long time, I thought that really I was just a terrible programmer and that the problem was with me. But what I've come to realize is everyone has this problem. You get given an objective, a task or whatever, and it's like, all right, cool, I know what to do. I'm just going to sit down and do some typing. And then I just need to add this, wait, oh, no. And it turns out that a decision that you made 6 months ago or 6 weeks ago or 6 hours ago has painted you into a corner, and you can't change the system and the dimension that you need to change it to achieve the outcome that you've been asked to achieve. Does that sound familiar to anyone? Yeah? And so how do we avoid this? What can we do? And like when you talk to people about this, like, oh, you need to do good design. Awesome. I'll just call Johnny Ive. What is good design? If you talk to programmers about good design, they give you all sorts of things, but the best definition I've ever seen comes from Kent Beck. And he says that programmers can add features steadily to well-designed software. Think about this for a minute. Who's worked on a system where as you went, it got slower and slower and slower to add new things to it? I know I have. I've built those systems. And I've worked on a few systems where we can maintain our pace, our iteration pace, or our feature value add pace, as we continue to add features over a sustained period of time. But that's Kent's definition, and he knows about building good software. He's done a lot of it. And the thing is that bad design is often self-evident. You look at a system or you look at whatever, and it's like, yeah, no, that's, yeah. But good design is invisible for the most part, or if it's not invisible, then it appears effortless. It seems simpler than it should be possible. And I've worked on systems that were very, very well designed by some very, very good programmers. And it wasn't obvious at the time that they were well designed. It was just easy to add stuff to them. So when I asked you, if I asked you, and I'm not going to because there's a lot of you, what good design was, you'd shout things out at me. You'd say things like, oh, it's simplicity, and it's modularity, and it's loose coupling, and it's being able to understand one thing in isolation, bounded contexts. Or it's design patterns. Design patterns are good design. Or it follows the solid principles. And I don't think that really helps either. So Gary Bernhardt, who knows Gary Bernhardt? He's a phenomenal guy. He's a great conference speaker and very funny. But I like him because he's sort of like an agony aunt for programmers and also a philosopher of programming. And he's written about this. And he says that the way that we talk about design means that the developers that you talk to internalize the reasons for their own failures and lead them into a cycle of self-blame. And this really resonated with me. It must be my fault that I can't produce good software. And he says, in short, pop cultural ideas such as testability, readability, elegance are easy to follow but hard to communicate across observers. It's easy to see if you sit down and peer with someone that this approach is more elegant than another. And I've done this with engineers, and they've done it with me, and I'm like, oh, of course, it's such a better way of doing it. But you can't teach that. You need to show it. But in contrast, Gary says, object-oriented design principles tend to be easy to communicate, but hard to follow. It's conference-ware, right? It's like, I can give you a presentation on the solid principles, and I can probably cover most of them pretty quickly, but you can't actually implement them in your code in an effective way without a huge amount of study. And Kent talks about this in this article he wrote on responsive design that I just think is incredible, where he talks about the fact that the more experience that a programmer has, the more design ideas he knows, and the temptation is to put those design ideas into the system now because you know you're going to need them in the future. Have you done that? I've done that. Oh, you know, I really need an event aggregator here because I know I'm going to need it for this thing down, and then, oh my goodness. He goes on to say that over-designing early leads to delaying feedback from real usage of the system, and it makes adding features more complicated and makes adapting the system design more difficult. But by the same token, under-designing makes adding features more complicated, increases defects, and makes adapting the design more difficult. You noticing a theme here? Design's hard, right? So he says, some design needs to be done in advance of coding, but over the life of the project, most design will be done in response to the changing needs of the system and the changing and growing understanding of the developers that are working on it. So what we need to do is we need to find some tools that we can use to improve design as we're working on the systems, because until we're working on them, we don't know the dimensions of change that are going to be necessary. So I want to talk about 3 ideas today really quickly. I want to talk about solid, I want to talk about coupling and cohesion, and then I want to talk about connascence, which is what I really want to talk about. So solid dates back to 1996. Who's heard of the solid principles here? Here's a list, everyone pretty much. Uncle Bob wrote about them in the C++ Programming Journal, series of articles. They're very rich, deep articles, lots of good thinking in them. The principles can be communicated quite quickly. I saw someone do a whole talk in an hour where he managed to cover them off pretty well. And then I saw this talk by Kevlin Henney a couple of years ago at Yale that blew my mind because he tried to deconstruct these and show why they're not actually really that helpful. And I'm not going to do the talk because you should just watch him do it. He'll do it a million times better than I will. But really what he comes out with at the end is that all of the principles boil down to one thing, that code should have a single reason to change, which is good. I think that's a reasonable observation. Who's violated the solid principles this week? Anyone? I might have, I don't know, right? I just don't know. I think that they're a useful didactic tool. They're good to study, but they're not good decision-making principles on the ground when I'm actually writing code. They're too abstract, they're too high level, and they don't answer a question for me of like, I need to do this thing now. I need to write a line of code. Should this if statement go here or there? Do I need to add a class here, or should I add a method to this class over here? They're abstract, they're not concrete. I think solid sucks. Come at me. So, because the problem is that fundamentally, if it is true that the solid principles boil down to a single reason to change, and I think Kevlin does a very good job of selling that idea, so I'm not going to try and sell it to you, you can go and watch his talk, but if that is what it means, then the contra to that is I somehow need to be able to anticipate future change in a system now. And we know that that's not going to work because Kent says that doesn't work, and he's done this a lot longer than I have, and I know that I can't do that myself anyway because I've tried, and then I had the event bus. So, Sandy Metz talks about this, and I really like what she's got to say. She's very, very big on programmers living with duplication longer than is comfortable, because her observation is that the wrong abstraction is far more expensive than eliminating duplication. Trivial duplication, and even non-trivial duplication, is normally pretty easy to remove. But if you get the wrong abstraction in place, then you can ossify a whole system around it and end up in a situation where you have an incredibly, incredibly traumatic refactoring to do, and it's not really refactoring, it's like burn that to the ground and start building again. So that's solid, that's the setup. I want to talk about coupling and cohesion. Who's heard of these things? Did anyone study this at university or somewhere? And I always found this really an unhelpful idea. You get definitions like this, Larry Constantine, attempting to divide. A cohesive module would only lead to increased coupling and decreased readability. It just seems circular to me. But then I did some study, and actually Kevlin Henney talked about this in a different talk at a different year. And he talked about this by contrast. He was like, well, so cohesion is in contrast to adhesion, and I think we've all seen adhesive code, I know I have, that just collects and accretes cruft as people drive past it. Code should actually represent the idea that it names, as the idea with cohesion. And so here's some public shaming of myself. Here's a type from our code base. It's dead now. It doesn't exist, but it used to exist. And at the time that I pulled this out, it had 33 methods on this particular type. dealing with 18 different concerns. Here it is. There's things like fetching entries from the database and updating them, and then there's things about authentication and logging in. And there's one there in the middle, which you can't read. It says ha, and it's called detach, and that's actually for dealing with the unit of work concern. And this is adhesive code. Does this seem familiar to anyone? It's just like there's no cognitive overhead to just throwing another method in here. It's like it's already rooted. There's no point in trying to design this better. It's stuffed. And the hilarious thing is, I'm not going to laser point this because I haven't tried it, but there are regions in here that actually describe the types that could be extracted from this. So it's like, oh, this should be like the merchant admin service, and this should be like the user login and authentication service. Someone had taken the time to annotate it. It's like, but they hadn't taken the time to break it apart. So cohesion is forming a united whole. So that's cool, cohesion. All right, what about coupling? Here's a service that we have in our solution, and it makes payments. And this is an important thing for us. It's what we do. We make payments. And it looks pretty cohesive. It looks like all of the things, it does one thing really, it makes a payment. There's a couple of different variants, but they all take the same input parameters and sort of return the same output parameters. How coupled is it? I can't tell from looking at the interface definition. And going to Gary Bernhardt again, he made this amazing observation. He said that in a very real sense, isolated testing done test first exposes design mistakes before they're made. It translates coupling distributed throughout the module into mock setup, centralized in the test, and it does that before the coupling is even written down. So let me show you the test setup for this particular class. Whoops. There are 18 collaborators of this type. It's cohesive, but it's a mess. And that's cool. This is great. This is exactly the sort of feedback that I'm looking for. When I come to write a test for this thing, if I need to add a new collaborator, then my little spidey sense can start tingling and go, oh, wait, no, this is going to make it worse. Objectively make this more coupled. Don't do that. So I've got now like a simple heuristic that I can use. If I have to add a collaborator to a mock setup for something that I'm doing, I need to step back and go, is this overly coupled already, or do I need to reconsider what's going on here? Making sense? All right, that's Gary, mock setup. This blog post is awesome. I'll publish the slides, but you should read it because he's good. All right, so here's my big point. I want to talk about connascence. So connascence comes from this guy, Mila Page Jones. He wrote this like academic thing in the communications of the ACM in 1992, where he was trying to find a software quality metric for object-oriented systems. Larry Constantine's stuff from the 70s around coupling and cohesion, they had metrics associated with this, but it was all for structured programming. It was like, oh, yay, we got GoSub, like, woohoo. And then it was like, oh, wait, now I've got spaghetti. And then they were like, well, we should try and measure this and find out a way of making it better. And what they found was when they translated that into OO, that there wasn't, the metrics didn't apply. And so Mila Page Jones was looking for a way to formalize a new set of metrics that we could use for measuring coupling in OO systems. I learned about it from this guy, Jim Werich, at Yale. He came and did a talk, totally blew my mind. We had lunch together afterwards, and he was very generous with his time while I asked him lots of stupid questions. And he actually died last year, which is a real shame, because he was a really generous teacher. And there's a fund for collecting money for scholarships for people about him. So anyway, he's called connascence, the grand unified theory of software design. And I think he was being tongue-in-cheek. He was being tongue-in-cheek. But I like his ambition. It's good. So the word comes from the dictionary definition of something that's born together or grows together or changes together, the act of growing with another. But in software terms, connascence is the software quality metric to allow reasoning about the complexity caused by coupling. And this guy, Kevin Rutherford, has just written a really good series of blogs on some of the connascences, which I encourage you to go and read, because he's done a great job of explaining them. But he says that it classifies the relative strength of coupling, and that means that connascence allows you to choose what to refactor first. Now, this sounds exactly like what I'm looking for. If I've got a big ball of mud, which bit should I fix first? If it's up to me, I'm going to fix the bit that's easiest. But connascence gives me a way of reasoning about this to say, oh, actually, I should do this first, because this is the most risky or the most harmful in the long term for the system. So I should address this particular thing before I address maybe some of the other things. So two software components are connascent if a change in one would require a change in the other in order to maintain system correctness. Connascence helps you quantify and safely anticipate change in your system. And the way that it works is there's a taxonomy. So there's a whole bunch of different types, and the types go from weaker to stronger. And you basically want to try and move your systems from stronger connascences to weaker connascences, except where you can't possibly avoid them. And you're always going to have some of the stronger connascences, and you'll understand why as I go through. But there's another dimension, which is the degree. So a few occurrences is less bad than many occurrences. And I've got examples for all of this, so I'm going to go through. They also break down into two types. There's the static connascences, which are properties essentially of the code. You can look at it by observing the code. But the dynamic connascences are affected by the runtime properties of the code, and so you actually need to reason through the actual runtime behavior. So that makes them much, much stronger and much scarier to deal with. All right, so we're going to start at the beginning, connascence of name. So I have a type here called customer. It's got an age property, and then I've got some client code somewhere else that creates a customer and sets the age property to 27. So I've got 1 degree of connascence of name. If I change that name property, then all of the code that uses that name property has to change. And you're sitting there thinking, this is the worst talk I've ever been in my life. And you're thinking, doesn't my refactoring tool, doesn't ReSharper fix this, or doesn't IDEA or Eclipse, lol. And that's the point. This is the weakest connascence. It's the best connascence. It's like North Korea is the best Korea. Connascence of name is what you want, most of the time. Sometimes. Actually, it turns out this can be very much more complicated than it sounds. And your compiler or your type system or your runtime can probably help you with some of these things. But here's another violation of connascence of name. Does this seem familiar to anyone? I've got a database table, I added an age column to it, and I've got a customer class that I also need to update to include an age column. Now, depending on exactly how those things are being matched up, there could be, and is likely, a hard binding between the name of the column in the database and the name of the property on my object. If I change one, I have to change the other. But the locality is wide, right? They're not in the same solution, they're not in the same file. I have to go and look at a whole different tool probably to find out what's going on there, right? So when we're talking about connascence, there's another dimension apart from the strength and the degree, which is the locality. How close is this occurrence of the connascence to another occurrence of the connascence? And you can't avoid this, but it helps you quantify, right? You want to seek to minimize the number of occurrences of connascence with distance. So, good locality within a method, bad locality between, libraries. And this is why libraries have to be frozen, right? In 1968 or something, someone made a function called sprintf. It's a terrible name for a function. Think about it. I'd like to rename it, but I can't. If I do, I'll break every running system basically ever published. Everyone's phone crashes. The whole thing's just a total nightmare. So you're stuck. So connascence of name, yep, fine, but distance. So this is an illustration of locality. What you're seeking to do is have strong connascence within a module or within a type or within a class or a file, whatever your unit is, but to seek to use the weaker ones where possible between systems or between things that are disparate. All right, second connascence is connascence of type, which is where multiple components must agree on type. It's very, very obvious. It's as obvious as the name one in some ways. Here's a function. It takes a string, does a hello world. I'm passing in an integer. The behavior is undefined. That's almost certainly not what I wanted to do. You're probably sitting there thinking, if you're a strong typing person, hey, my compiler tells me about this. And if you're a Haskell programmer, you're probably right. If you're not a Haskell programmer, then your compiler will only help you sometimes. And here's another example with a database, just because it's really easy to illustrate. But there's lots of cases where even your type system won't help you with this. But if I have a type stored in the database as an int, but I'm representing it as a decimal in memory, then there's types that are representable in memory that are not persistable. And I've personally experienced this bug, and I'm sure some of you have as well, where you map to the wrong type, and then you lose data in really weird and unexpected ways and sadness. F# type providers might help you here if you're a masochist. But overall, this is still something you need to be aware of and plan for. So connascence of meaning. Connascence of meaning is where multiple places must agree on the meaning of a value. And in our solution, we have this sort of role-based security thing that uses strings to represent roles. So we have this can-do-everything role, and then we annotate it on an action, and then we have some framework enforcement of that role on the way through, and we use it in multiple places. Now, can-do-everything, as it turns out, doesn't actually mean can-do-everything. It means can-do most things, apart from some things. We'd like to rename this, but if we do, we have to change every occurrence of that string throughout the whole solution, or the code is not going to be correct, so they're connascent. Now, you can see, and I'm sure lots of you are much better programmers, and you're thinking, oh, well, we can just introduce a type and put a property on it that represents that string, and you're exactly right. We've turned that from connascence of meaning into connascence of name. And that's the whole point. You can move up and down the connascences, and generally speaking, you want to move up. You want to move from stronger to weaker. This comes up in lots of other situations, and it can be much more subtle. A classic example is where you have a method that returns a thing, and if it can't find the thing, then it returns null. So you have a connascence of meaning here. Null has a specific meaning as a return result from that method, and it means that thing does not exist. And that might be okay or it might not, but it can lead to very difficult refactoring situations later where you have multiple different not exist scenarios. And so people say, oh, you should use the null object pattern, which means you introduce connascence of name, and you do a comparison against that, an equality comparison against that to say, oh, when this thing doesn't exist, if the thing I get back is the same as the does not exist thing, then I'm good. And now I've moved from connascence of meaning to connascence of name again. So this explains why this is why these patterns are a good idea, or why avoiding particular code smells are a good idea. This comes up with empty strings. It also comes up with special values. And I mean, who's ever seen code like this? In our solution, we have like test cards. And originally, we only supported MasterCard and Visa. So we had like a couple of branches in our code where it's like, oh, if the card number is this special test card number, then do this thing, which was cool. But then we added support for a couple of other card brands like Amex and Discover. And Amex numbers aren't even 16 characters long, and they certainly don't start with 4 ones. They weren't valid card numbers. And the thing that is great, right, is that connascence explains why doing this refactoring is a good idea. Like intuitively, I know this is a good refactoring, but connascence says, oh, I've transformed this from connascence of meaning, which is a stronger connascence, to connascence of name, which is a weaker connascence. It's not my opinion. I'm not saying, oh, your code sucks. I'm saying, hey, we can move this from one of the higher, stronger forms of connascence to one of the weaker ones. It gives me a reason. All right. Here's another one where this comes up. This is a code smell called primitive obsession. Has anyone heard of that? Primitive obsession. So I've got a type here called payment, and it's got a property on it called amount, and I'm assigning some variable to it, some value to it. But it doesn't, there's some important things that are not considered in this. So if this is representing money and not like buckets of water that I've carried up the hill for Liza, then what currency is it? And what conditions can I ensure that I don't violate the business rules? I cannot add American dollars and New Zealand dollars together and get a valid result back unless I do a transformation. And so I should be seeking to make sure that's not possible to represent that scenario in my code base. And connascence of meaning is like, no, your code should have meaning. So we can introduce a money type, and we can put an amount and a currency on that type, and then we've got a nice thing. We've changed connascence of meaning to connascence of type. Does that make sense? Yep. Next. All right, connascence of position. So connascence of position is when the order of things is important, and the most obvious place where this could ever occur is the order of arguments to a method. Everyone says, well, you shouldn't have methods that have many, many arguments or functions that have many, many arguments. And the reason why is because connascence of position. If I need to change the order of these, everywhere that I call this code has to change as well. So if this is 2 degrees of connascence of position, it's no big deal. But if I have to add a parameter to this method, everywhere that this code is called has to be updated. And I'm sure you've all been through painful refactorings where that's happened. And that's why. And then if I go to this, I'm suddenly up to 6 degrees of connascence of position. All of a sudden, I've got a real problem on my hands, especially if this is called from a lot of places. So 6 degrees of connascence of position in a private method that can only be called within like one class or one file may not be a big deal. But 6 degrees of connascence of position where I'm calling it across many, many different types across a whole big project could potentially be a real major refactoring problem for me. Now, you've heard, or maybe you've heard of, using argument objects or parameter objects, and this converts connascence of position into connascence of name or type, depending on exactly what language you're using. But this is why this is a good idea. Oh, we'll just wrap this up in a type and pass it through, and then if I need to add another parameter, I can add a parameter to that type that I'm passing in, and I don't necessarily need to update all the call sites. Maybe. Connascence of position also comes up more in dynamic languages if you have tuples or arrays where the index into the array has meaning. So in this case, the second element in this array is actually representing an amount. And so that's a much stronger form of connascence of position. It's still connascence of position, but this is a more scary one and one that you would be wise to convert. You can imagine how you might convert this into a hash table or a dictionary or something and make it connascence of name. All right, connascence of algorithm is where 2 or more places must agree on the same algorithm. For us, this crops up in a really frequent way that is sad, validating mobile phone numbers. I know that sounds silly, but validating mobile numbers across international borders is hard, and we have to do it across multiple tiers. We have to do it on iOS, Android, we have to do it in JavaScript, and we also have to do it in our back-end systems. And unless they all agree on the definition of what a mobile number is, you can end up with users getting into a situation where one place will let them put in a number and say, hey, that's totally valid, no problem, but then another place will be like, yeah, that number's not valid, and then sadness. So it also crops up doing crypto. If you're doing like a HMAC or a signed hash or whatever, you've got to make sure that you set up all of your input variables right before you do it, and you've got to make sure if it's across platforms that both the implementations produce the same hash for the same input, and if they don't, then you can end up in a very bad situation. This also crops up, another example of connascence of algorithm is in routing. So you have this input URL, and you've got some router that translates that into a controller action pair, or if you're a node guy or node person, it just translates it into a function, which is neat. But then on the other side, you've got to render those URLs again, and you've got to make sure that they end up back at the place we need them to go. And different frameworks handle that differently, but you can have a connascence of algorithm there. ASP.NET MVC translates that into connascence of meaning, which is half a step forward. There's libraries that then translate that into connascence of type or name, which is neat. So there. All right. So the static versus dynamic connascences, we're going to just look really quickly at the dynamic ones. I don't really have time to go into them. But we have connascence of execution, which is where the order of execution matters at runtime. The most classic example of this, or archetypal example, is in locking. You need to acquire your locks and release your locks in the same order everywhere that you use them, and if you don't, you get deadlocks and sadness happens. Connascence of timing is where the timing between of execution matters, and the classic example here is when you have two threads accessing shared mutable state, and when you do that, you can end up with race conditions and sadness. Connascence of value is when two values must change at the same time in order to continue to be correct. And the canonical example of this I really dislike because it's trivial, but it's if you tried to define a triangle type by the degrees, the angles of incidence of its vertices, then if you change one, the others would have to change, otherwise you would cease to have a valid triangle. But I've got a better example, so yay, I'll show you that in a minute. And then connascence of identity is where the identity, where multiple components must reference the same entity. So this comes up when you implement hash codes, and if you do that wrong, then you can put things into hash tables and not get them out again, or get the wrong thing out again. I've personally done that, it's not a good idea. And it also comes up when you are implementing a unit of work or using a unit of work where you have an object in memory that represents a row in a database, and it's fetched multiple times, and you want to make sure that every fetch gets the same object instance in memory, otherwise you can end up losing writes or doing partial writes or losing data. So connascence of value, the place where I've found this actually creeps up is in unit tests. Unit tests can end up knowing about the initialization state of the objects that are under test, which makes it very, very hard to change those objects later. So who's ever written a test like this? This is the simplest example, but we've got this property on this object that's set at initialization to draft, and then we've got a test, and you can imagine it would be much more complex than this, but then it's asserting that that state is unchanged. And what we've got here is we've got a connascence of value violation, and it's a very, very strong violation. It can lead to really fragile unit tests, because if you need, for whatever reason, to change the setup of that object at initialization, you're going to break a whole bunch of tests, which is, yeah. And we have a lot of tests, and we have a lot of bad tests because we're all learning, but that's fine. But we have a lot of tests that kind of violate this kind of stuff, where they actually know about the internal details of the object, rather than asserting that the state is what they expected it to be. So you can imagine how in this case you would translate this into, you could put a property on the object, which is like initial value or default value, and then reference it, so then it's connascence of name. But it can get much more subtle than that very quickly. All right, so within a module or within a type or a class or a file, we expect more connascence. It's normal for there to be connascence, and connascence isn't bad. It's just a way of describing it and comparing the relative strengths of it. So that's not bad. But lowering connascence between modules makes modules more cohesive because they know less about each other. Ultimately, they maybe just know about the name, or the name and the order of the arguments, or the name and the order of the arguments in the type, or whatever. And that's because it's easier to change the weaker connascences, and it gets harder and harder to change them as you move down. So if you keep them close together, then the change isn't spread across your whole system, but it's localized within a small area that you can keep in your head at once. You don't have to remember, oh, I changed these things here, but now I need to go and change these things over here as well. So one weird trick for better code, a grand unified theory of software design, connascence. That's it. Are we taking questions?
We've got time for questions. One here.
Cool. You were kind of laughing at a bunch of tools throughout that, but do you have any that would help with this for analyzing or refactoring any of our own?
Yep. This one. No, I don't think there's any. I'm not aware of any. Some of the IDEs have some tools for measuring coupling built into them, but the thing about coupling is now that I know more about it, I realize there's many different types, and some types are worse than others, and I think it'd be really hard for a tool to analyze that. So, yeah. Good question, though. You should build one. Anyone else?
Down here. Remember to put your hand up nice and early. Don't make me run.
Your slides are going to go up online?
Yes.
With that, is there some recommended reading on this? Because it seems like a pretty cool idea to...
Yeah, it's a very cool idea. So there's actually some links. I think we've lost my slides now, but on the last slide, which I didn't show, there's a couple of links to a talk by Jim Werich, where he talks about this again, and he does a much better presentation than I do, so it's worth listening to that. And then also Sandy Metz, she doesn't actually talk about connascence, but she talks about all the little decisions that lead to good design. So she doesn't use the same vocabulary, but it works out the same. So yeah, yep. Show us the slide. If we get the AV, yep, way, there we go. It's like magic. Jim Werich's website is offline because he stopped paying his hosting bill. So in the middle, he made like a catalog of the connascences, and it's very, very light. It's actually, the data is now all in Wikipedia, I think. But that's his original sort of setup for describing all the connascences. So it's worth looking there. And then there's some other, I've got some links throughout the rest of the slide deck as well to other good reading material on it. So, yep. Anyone else? We out of time?
Up, down the front.
I can't really see, sorry. I'm dazzled. Oh, it's Ivan.
It's that Tolson character.
What approaches do you have for reducing the cross-locality problem? You gave the example of, and it's an absolutely classic problem, of the connascence of name across code and database.
Yep.
And we can all think of other examples like routes from client, connascence of route between client and server, which again, connascence of meaning, I guess.
Yep.
What tools do we, well, maybe not tools, what techniques, how can we centralize that information to reduce that connascence? Don't point at your head again.
So I've been banging on about this for a while, and you know I have. And so in our code reviews, it doesn't really happen, like we use GitHub for actually like commenting on PRs and stuff, but it's more about in discussions with engineers, we'll be like, oh, that's a bad connascence. It's an observation as we go past things. You can't avoid it. I don't think that, like, all code has to talk at some point in time. You've taken the microphone away from Ian, and he wants to rebut me.
Be nice.
I don't want to rebut. You've distracted me from my point now. I guess what I'm looking for is how do you identify? So when you do a code review, you may be saying, oh, we're going to change the name of age to years since birth. Well, hang on. Now, how can I locate the references? You know, we had a connascence name which is the weakest type. It's the best type. But still, because of the locality problem, I can't actually trace that connascence outside a very small arena.
So for us, in our specific context, like you seek to keep all of those connascences together. So all of our database models for a particular problem space will live together. So when they change, we know they need to be carefully reviewed. It's not that we keep them with the SQL scripts. We know, okay, if something changes here, we have to carefully examine this and the database migration to make sure that those things are in sync. So we can't keep the locality of the database. We can't get that any closer, really. But what we do know is, oh, a change in this is a high-risk change, and it needs to be reviewed alongside these other things. And we also use approval tests, which now I'm getting way into it, but we have things that warn us if things that shouldn't change, or at least if they change, other things need to change. So we actually have tests that fail every time you change routing, so that we know, oh, wait, I inadvertently changed a route that's been published that might be depended on by a consumer, and I can approve it quickly, but at least I know I've got a red flag to verify in my head. Done?
I think we're done. I think that's
cool.
That's it.
Come find me afterwards. I love to talk about this stuff.
Yeah, that's it. So thank you, everybody. Thank you, Josh.
Thank you.